Hello, boys and girls. Welcome to Mrs. Bandu's Math Movies. This is a video for Course 2, Lesson 2-7, Rational Numbers. What we'll be doing here is not only defining what rational numbers are, but comparing and ordering them as well. Okay, so our first thing is the definition of a rational number. And a rational number is a number that can be written as a quotient of two integers where the divisor is not 0. Okay, so again, a rational number is a number that can be written as a quotient of two integers where the divisor is not 0. Okay, first of all, the divisor cannot be 0 because division by 0 is undefined. We have touched on that a bit in class. I'm sure we'll discuss it again just a bit when we go over this section in class. And remember that what we're talking about here is generally looking at a fraction. Okay, so if we can write the number as a fraction, then it's going to be defined as a rational number. All right, so first we want to look at comparing rational numbers. If we want to compare -1/4 and -3/8, one way of doing it is by looking at a number line and finding those two values. -3/8 is right here, -1/4 is right here. Since -3/8 is further to the left on the number line, it is the lesser number. Okay, so remember, when you're looking at negatives, the farther away or the farther to the left a number is from 0, the smaller it is. Okay, so in this case, -1/4 is closer to 0, so that makes it greater than -3/8. Okay, that's kind of the reverse or the mirror image of what you consider on the positive side of 0 on the number line. A second method would be to rewrite the fractions with a common denominator, which sometimes can be, depending on how comfortable you feel with the number line and graphing, or, would you rather look at common denominators? You're going to have choices of how you want to do these. Again, in this case, I would try to use the thing that seemed the easiest to use and the most relevant at the time. Okay. So, first of all, it says rewrite -1/4 with -1 in the numerator. And as a matter of practice, I normally do that anyway. The least common denominator for 4 and 8 is 8 because I'm doing 1/4 and 3/8 again. So I'm going to write an equivalent fraction. Okay, so -1/4 times 2/2, multiplying each by 2, gives me -2/8. Okay, so since -2/8 is closer to 0 than -3/8, -2/8 is greater than -3/8. So therefore I can say that -1/4 is greater than -3/8. And in this case, again, if I just consider numerators, -2 is closer to 0 than -3. Okay, so that's going to make the -2 larger. So -2/8 is greater than -3/8. Gives me my final answer of -1/4 greater than -3/8. So you can use a number line or you can use common denominators. Be careful when you have negative numerators because you want to be sure that you're comparing them as you would negative numbers. Okay, you have a quick check here. You can do it now if you want to pause, or you can come back to it later and complete all your quick checks at the end. Okay, here we have comparing decimals, and we just have a series of decimal numbers here. We want to compare using less than, equal to, or greater than. Okay, in our first example, 2a, we have 8.7 and 8.1. Both numbers are positive, so we're simply going to compare the digits. Both have 8 in the ones place. 7/10 is greater than 1/10. So 8.7 is greater than 8.1. Okay, part B, negative 8.7, and we want to compare that to 8.1. Okay, this one is pretty straightforward because any negative number is less than any positive number. Okay, so there's not a whole lot involved in that other than knowing that this is going to be way to the left on the number line. Anything negative is going to be less than anything positive. And finally, we have negative 8.7 and negative 8.1. So again, here we can do the idea of placing these on a number line. Right here would be negative 8.1. And 1, 2, 3, 4, 5, 6, 7. Here we go. Negative 8.7. So we would see on the number line that negative 8.7 would be to the left of negative 8.1. You can also sort of use the idea of, again, back to what I said with the example number 1. Both have negative 8, so I'm really going to be comparing the second digit. Negative 7 is further away from 0 than negative 0.7 is further away from 0 than negative 0.1. Okay, as you see how they end up on the number line. Again, number lines can be very helpful if you're getting confused on what you're wanting to do. If you're able to reason through these kind of questions, that is certainly appropriate as well. Okay. Which list shows ordering rational numbers? Which list shows the numbers negative 3/5, 0.625, 2/3, and negative 0.5 listed in order from least to greatest? And then you have a variety of options here that you will see. Okay, again, similar to what we did in an earlier problem, I think probably in the last section, we can go ahead and write these as decimals. Okay, so this is negative 3 divided by 5, which gives you negative 0.6. This is negative 2/3 gives you 0.6 repeating, and now you have everything turned into decimals. If you need to plot them on a number line, you can do that. Again, sometimes it's helpful perhaps to just jot them down so you can compare them digit by digit. Don't forget to include their decimal, their positive or negative signs as the case may be. And now the negative 0.6 repeating, remember, is a string of 6s continuing on. Okay, so when I look to see which one is going to be furthest, and this one is positive. Which one is going to be furthest from 0? I see the negative 0.6. Oops, so negative 0.6 is less than negative 0.5. All right, so I just had to compare the two negatives. And then the next number in order would be the 6.25, which is going to be less than, I keep saying it incorrectly, 0.625, which would be less than 0.6 repeating. Okay, so here are my decimals, and now I need to go back to my decimals and line it up with my numbers. So from least to greatest, the numbers are negative 3/5, which is the equivalent of negative 0.6. Negative 0.5, 0.625, and 2/3. So the correct answer choice is answer A. Okay, you have two more quick check questions here. Certainly, please do these and bring in any questions that you might have, clarifications. We will do some more examples like these just to be sure that you understand what you are doing. I look forward to seeing you in class. Thank you.